Okay, so it's gonna be more algebra. We have a lot of algebra problems and stuff, so let's dive right in. Okay, let's start with just basic operations with expressions, I guess. So suppose you want to do this, 3x squared. It's just like terms in essence in this problem, 5x minus 6 minus negative 2x squared minus 6x plus 7. So let's distribute first so we don't get messed up. 3x squared plus 5x minus 6 minus a minus is plus 2x squared minus the plus 6x, and the minus, the plus is a minus. Okay, 3x squared, 2x squared, that's 5x squared, 5x, 6x, 6 plus 5, 11x, and that's a positive. So that's done. That's done. Okay, negative 6 and then minus 6 and minus 7, which is 13, and it's gonna be minus. So that's your answer. 5x squared plus 11x minus 13. And you move on. Okay, let's just simplify this expression. This is actually a difference of two perfect squares, which is also called dots, by the way. Difference of two squares, which is exactly what it means. Difference, so there's a minus sign, of two squares. X squared is a square because you could do x squared squared, and 16 is a square because 4 squared is 16. So how you would solve this is that becomes x squared plus 4, and then x squared minus 4. Just changing the signs, and then you take like a square root essentially of both. So yeah. And if you don't believe or if you don't know, just test it out. X squared times x squared is x to the fourth minus 4x squared plus 4x squared. So it cancels out, and then you just have negative 4 and 4, which is 16, negative 16, which is exactly what you get. In this case, you can actually also simplify this. This is also a dot because it's x squared minus 4. Difference, two perfect squares, which becomes x plus 2 then, and x minus 2. And that's how you simplify that. All right. Okay, just as a, so if you have this expression, 6x to the, actually, let's just do the degree of a polynomial. It just basically means the highest degree in a sense. So like 2x squared plus x. The degree is just a 2 because that's like the highest thing you have. It's a quadratic instead of like a linear. It's not linear, so yeah. So if it's a fifth degree with a leading coefficient of 7, so it'll be 7 x to the fifth in essence. Okay, and then you can have some other stuff like, I don't know, like other stuff. And then if you have a constant of 6, it should be like this. Constants are obviously just numbers. So yeah, that's how you write it. So fifth degree, constant of 6, leading coefficient of 7, and yeah, that's about it mainly. Okay, let's solve, or let's factor this to get the answer. So the zeros of this expression. Okay, let's do this and then set equal to 0 because that's what you do to find the zeros. Okay, negative 6 and a 5. So I could do 3 and 2 works, I believe, but that won't give you negative. Okay, 6 and 1 and 3 and 2 are the two choices. Minus 5x minus 6. Let's try two things. What two numbers gives you 6? Let's try 2 and 3, maybe. If you want to do negative, you have to like, you can't do this because that will give you a positive 6. So you have to change the signs. And I don't think so that will work. So let's try the other ones. 1 and 6 because that will give you that. Let's see if this works. Let's see. I'm just guessing and checking, which is a really good method in these kind of situations. So x times x is x squared. 1, like x times negative 6 is negative 6x, plus 1 is negative 5x. And then 1 times -6 is -6, which is good. So you have this, and then you set equal to 0, so you get x equals -1, I believe, and x equals 6. And you move on. Yeah. Okay, let's solve another problem. 2 times x plus 2 squared minus 4 equals 28. Okay, let's see what we could do here. Initially, what we want to do, let's see how this works out. Plus 4. Yeah, because you want to try to get x by itself in a way, because you're gonna have to take square root of probably the entire expression. Yeah, so that's 2 times. Actually, I'm just gonna do the math first. This becomes 32. 32 divided by 2. It's gonna be 16. So it's basically gonna turn into this. And in this case, you could take the square root, which is good because this is, good. So it's going to become x plus 2 is equal to, now notice this is very important. The square root of 16 is positive and -4. There's 2 answers. That becomes x plus 2 equals positive 4. So -2 minus 2. So x equals 2 in that case. And then you do x plus 2 equals -4. And then we do -2 minus 2. So x equals -6. So yeah, you gotta be real careful about those two, the fact that there's a positive and negative, that will trip people up, but yeah. Suppose f of n, a function of n, is n minus 1 squared plus 3n. You want to find out what f of, for example, I don't know, -2 is. Let's just plug it in. That's all you gotta do. What is this? 3 times -2. Okay, so -2 minus 1 is -3 inside the whole thing. If you square that, you get 9. And then 3 times -2 is -6. So 9 minus 6, which is 3. And that's a fact. Yeah, that's all. It's a function. You just plug it in. Okay, so suppose you have a graph. This thing is just, it's f of x. And basically, you have another function that's like this. It basically asks you how many spots are they equal, like the two functions, suppose to g of x. It's actually 2, and assuming this like goes there, whatever, so it doesn't like intersect anywhere there. This goes on forever, goes on somewhere here, and yeah, like this, that, yeah, suppose like that. It's gonna be 2 real spaces, wherever they intersect, honestly, is the answer. So in this case, I see 2. That's about it. Just see where they're equal to each other. The values. Okay, let's solve for x again, zeros. Actually, 0 is not the x, really. If you have x minus 3 squared minus 41 equals 0, I'll just set equal to 0 because that's how zeros are. Add 49, add 49. Okay, so you're going to x minus 3 squared equals 49. I could already see the square root coming. So it's going to be x minus 3. Again, this is important. It's going to be plus or minus 7. Because that will lead you to believe it's x minus 3 equals positive 7. So plus 3 plus 3, that's going to be 10. But you can also have x minus 3 equals negative 7. In this case, if I add 3, negative 7 plus 3 is negative like 4, I believe. So yeah, those are 2 answers. And remember, there are 2 answers because ultimately this is a second degree equation, quadratic in that sense. So yeah, that would make sense. Okay, let's do this. You have 4 times ax, where you don't know a, but you can have solved the equation in terms of a. Your goal is ultimately to solve for x in terms of a. So a, we don't know, but we can leave it in our answer, so that's fine. We want to solve for what x is. We have this equation. It's just a lot of manipulation in a sense. 25 plus 3a. So 4 times in parentheses ax plus 3, close parentheses, minus 3ax equals 25 plus 3a. distribute. That's the best option because you want to get the axes, you know, together in that sense. So you get 4ax plus 12 minus 3ax equals 25 plus 3a. I'm just going to subtract the 12 because we want to get the constants really in one place. So you're going to end up getting 25, and you can just subtract the 12. So you're going to get 13. So you get 4ax. Actually, I'm just going to not even do that. Like if I see something already. 4ax minus 3ax. It's just ax. And then that's going to equal to the left side is done essentially. And then it's just ax, it's not done. And 25 minus 12 is 13 plus 3a. All right, so what you could do, you could just divide by a. And that's your answer, because we could leave it in terms of a, which is fine. There's no number for x. Okay. So that is the answer for that problem. Okay, let's see. Let's do this similar problem, kind of. Or just simplifying, actually. It's not really that similar in a way. 2 times 3g, now your variable is g. You don't want to solve for g, you just want to simplify it in this case. It's actually an expression, not an equation, so you can't really do much. Distribute. That's a very important rule. 6g minus 8. Remember, there's a minus, so you have a minus 8g and then a minus 3. So you do 6 minus 8, which is negative 2g, I believe. Yep. And then negative 8 minus 3. And it's negative 11, and that's it. That's all the question really asks. Just simplifying it in this case. We can also go out onwards, but you don't have to. All right. Let's see. 13 minus 36x squared equals negative 12. If I do plus 12 plus 12, what do we have there? We're gonna have 13 plus 12, which is 25. You bring the 36x squared. I'm just trying to make stuff positive. We are solving for x, by the way, I believe. So that's gonna be 25 equals 36 x squared divided by 36 divided by 36. So you can have, it's kind of special-ish, x squared equals 25 over 36. So yeah, you can take the square root. In this case, they're actually both perfect squares. Square root 25. You could. This is a fundamental fact. So yeah, we're left with this. X squared equals 25 over 36, I believe. Yes, like this. So the fact is, you can just break that up into. Actually, it's x equals, not x squared equals, because we took the square root to get rid of that. You could just do this, noting the plus and minus, because that is a thing. So yeah, but let's do the principal root maybe, which principal means it's a positive. 5 over 6. But yeah, in a sense, that's a way. You can always plug it in, but there's also a plus minus. So yeah, that's your problem. Okay, last problem in this. Determine the product of these two numbers, so multiply them together. Is that rational or irrational? 1 second, actually. Yeah. Actually, it's 18. It's not 16. I don't know what I put there. Yeah. So it's 3 square root 2 times 8 square root 18. So when you have square roots, you can just multiply the things together. So and everything's been multiplied together. So just do 18. 8 times 3 because that's easy. 24. And that becomes square root of 2 times 18 inside, because you could do that. You can multiply to get into one sense. The same way you could do, let's see. If you do square root of 4, that's, the answer is 2 times 2, which is 4. And then you could also do square root of 4 times 4, which is 16, which is square root is also 4. So you could do that just as a check. Just plug in numbers and check. That's the best option. So 18 times 2, I believe, is 36, which is a perfect square actually. It's just 6 or negative 6 or 24. It's actually rational because these are all, real rational numbers. So yeah, that is the end of this session about a lot of algebra stuff. Thank you.